A very good morning to all of you and a warm welcome to my webinar on war on wastes, a practical approach. Gentlemen, yesterday I was discussing with a friend of mine about this webinar, and he told me that, Dr. Bhattacharya, why don't you change the name of this program? So I was a little bit surprised. I said, why you are saying so? So he said that look at the picture at the bottom and what this gentleman is doing. He's not waged any war against anybody. He is just cleaning the floor. So why don't you relate it to removal of waste or something? So I said, okay, I'll name it as get rid of waste. The gentleman, my friend, he looked at the sentence and he said that Bhattacharya, this is an excellent program, excellent name rather, because if you take the first letter of each of these words, GROW, so what does it indicate? You really grow. So, gentlemen, I will call it a grow program instead of war on waste. I accepted the suggestion of my friend and I said that I will go for grow program. So this slide gives you my resume, or I need not explain anything. You can always see later on. So what is black swan theory? This is a black swan, and this theory was developed by Nassim Nicholas Taleb, and he explained like this. There are some incidents in the world which are hard to predict. For example, the war or destruction of the World Trade Center, tsunami. So what is said actually, the disproportionate role of high profile, hard to predict and rare events that are beyond the realm of normal expectations in history, science, finance, and technology. So you cannot imagine the extent of damage it can cause. The non-computability of the probability of the occurrences. So probability of the occurrence cannot be decided or by any scientific method owing to the very nature of small probabilities, maybe probabilities to the tune of 1 into 10 to the power minus 10. The psychological biases that blind people both individually and collectively to uncertainty and to a rare event's massive role in historical affairs. Now, can we say that corona pandemic is a black swan incident? Experts will debate whether it's a black swan incident or a white swan incident or a black bull incident. That's up to them. But to me, when I read this in the Wikipedia, so I thought that it's definitely a black swan incident. It has affected the whole world and nobody could predict the amount of destruction it will cause everywhere. So you'll have to assume that chaos will be normal. So chaos everywhere. When you go for restarting your operations, what you will see, you will not find your suppliers. Suppliers are not in place, raw materials not in place, your machines are not working, your workers are not in place, your distribution network is not in place. So everything is chaos. So it's simply chaos. And same thing had happened when after the World War II, when the Japanese company was struggling to manufacture the cars. Toyota is one of them. And what they did actually, they improved the processes, they trained the people, they trained the suppliers, they introduced some systems like TQM, TPM, 5S, etc., etc. And they, at the same time, they automated the whole systems, and that is how they were successful. And what did they do? They actually removed the waste. Now, this is what the K. Watanabe, president of Toyota Motors, said, that I'm a very curious person by nature. My character leans towards aggressiveness, and I like it that way. I immediately recognize the problem, know right away that something is far too expensive, that something needs improvement. I notice things and I don't resist change. So change is the only permanent thing in life. So let us all remember that things will change, and that is the only permanent thing. So this is from K. Watanabe, the president of Toyota Motors. So I remember one incident. I read this story that initially there was a tremendous quality problems in Toyota production line, and whenever the conveyor line for the final assembly, there was some problem in some stations in the line. The people used to stop the conveyor, and after rectifying it again used to start. Now, as a result of that, what happened? Every few minutes, 1 minute or 2 minutes, the line was stopping, and ultimately they were not able to produce the car to the extent they desired. And it was really a horrible situation. The matter went to the president. Now, the president said, he discussed with the people and then took a decision. He said that you can stop the line, but you cannot start the line. For starting the line, you will have to take my permission. And the problem started disappearing. People started discussing among themselves as a team and find out solutions of the problems. They understood that if there is a problem, we'll have to solve it. Nobody from outside will come, or president or vice president will come and solve it. It is we who will have to solve it. And that is how he solved the whole problem. And the bell stopped ringing and the conveyor continued to run. So what is waste? Another president of Toyota, he said that anything other than the minimum amount of equipment, space, and workers' time, which are absolutely essential to add value to the product. What is said actually? That if it doesn't add value to the product, please consider it as a waste. Now, if I ask you frankly a question that, is inspection a waste? Now, some of you will say, no, inspection is necessary because otherwise my product will have problems. Now, the same question was raised by somebody in a meeting when I was in TVS Group companies. I said, I say to the suppliers conference, I was asked these questions, and I told the suppliers that if I am to inspect your product, it will be an insult to you. They said, how? I said, you are checking the material and I am checking the material because I don't believe you, so that's why I check it. But if your checking method is same as my checking method, then why it should get rejected at my place? I'll not go for any inspection of your products if I have faith in you. Since I don't have a faith in you, so naturally, I inspect twice. So that is what we found out with the suppliers, and the suppliers started gradually improving the things. So Toyota principle is based on PDCA plan. What is that? P means surface problems. Problems must come out to surface. Then you take measures, then you evaluate the results, and then you create the flow. And the heart of the whole thing is what is called elimination of the waste. So by following this principle and introduction of various systems, training of the people, training of the suppliers, etc., training of the dealers, So like that, they followed the principles and they came out from the bottom of the pit to the top of the world. So what should we do when we restart the operations after COVID-19 lockdown? You would be under tremendous pressure to reduce cost on one side and deliver fast on the other side to satisfy your customers in a completely new environment. It's a virtual war with conflicting objectives. You will not be allowed to work with full people. You'll be allowed to work with 30% of the people. You will not be allowed to work with all the machines, because with 30% people, you cannot run all the machines. Then if you cannot run the machines, then you cannot get the products. You cannot get the components. Same with the suppliers. Suppliers will run with the 30% people. Now they cannot supply you the product you desire. Same with the raw material supplier. So it's a virtual war. So fighting between you and the supplier, you and the production people, and so on and so forth. So all objectives are conflicting, but still you will have to manage the situation. Gentlemen, we face similar problems in TVS Group companies 2 decades back. When I joined TVS Group companies, a one group company in the group, which was in shambles. And we embraced the GROW program to come out of the situation. And at the same time, we organized training of the people, training of the suppliers, and then our profit level was virtually nil and it was negative. And we had to work 24/7 to gain the objective. So let us see what we did. We embraced the GROW program, get rid of waste, remember? Then the program was based on 3 guiding principles. Focus on joint costs, focus on cross-functional teams. You must have a cross-functional teams. You must allow the people to come together, and we should utilize their strengths. And that is how we will be successful. Then focus on TCO and not purchase order price when we talk about purchase. This is an accelerated plan reductions. This resulted in accelerated plan reductions and improved the bottom line. And when you do that, you just grow. Now, this is based on using TCO to determine hidden costs and making correct decisions. For example, if the purchase cost is tip of the iceberg, here it is, and just the tip of the iceberg, and internal cost is somewhere here, and joint cost is somewhere here. So you continuously minimize the total cost of ownership and you achieve what you desire. So this is the savings aspirations you derive from the spend base of the companies. And our spend base was around 128 crores, raw material and bought out, subcontracting 16, other commodities 18. So if we put all together, it was 162 crores. And savings as per spend base, it was 5, 10, 10, 6. So 6% we wanted to save, and it resulted in actual value of 9.8 crores. So it is approximately 10 crores. Now what happened? We took this proposal and went to our chairman. We went to chairman and presented this. My chairman looked at me and smiled. I said, sir, we have done whatever is possible and I cannot go beyond this. My back is on the wall. Chairman said, break the wall. Please go anywhere in the world. And I want a reduction of 15 crores per annum. Instead of 10 crore, it was raised to 15 crores. So you can imagine what we'll do. So for your information, I'm just putting something here. Effect of cost reduction on return on investment. So top one, this one, operating cost elements, and the bottom one is assets. And if you multiply these two, you get the return on investment. Now, what is the return on investment? It is 10%. Now, if we decrease the material cost by 5%, then what will be the result? So net income is 515,000 and profit margin is 10.3%. Similarly, there will be slight change in the asset turnover rate. It is 1.26 and return on investment has gone up to 13%. That means 3% improvement on return on investment, which is a very huge thing for any organization. And chairman probably had an idea that he used to tell us always that, Mr. Bhattacharya, we want an interest rate of more than what bank pays us. Then only I will invest the money for you. Now that time the bank was paying around 12 to 13%. So keeping that thing in mind, probably he talked about 15 crores. So we gave a thought to it, and we decided that we'll have to do both innovation as well as Kaizen to improve the things. Kaizen is nothing but small improvement. Japanese people, they call it Kaizen. And you must be knowing that Sundaram Fasteners was the first people to get ISO 9000 in India. TPM also for the first time. TQM also as Japanese concept we introduced in India for the first time. And this, if you want to go for world-class manufacturing, you will have to go for innovation as well as Kaizen. Kaizen is a gradual and continuous improvement, and innovation is rapid and intermittent improvement. And then only you can have the competitive advantage. Now, so if you ask me what is innovation, innovation is nothing but see what others see and think what none think. So, gentlemen, this is the crux of the whole thing. That is what we did, and we took the company from bottom of the pit to the top of the world. So that is how we have done it. So I'm going to give you a lot of examples. There are hundreds of examples, so I cannot give you in a short time like this, but I'll just put it that world-class manufacturing actually is nothing. You do not know what you do not know. So it opens minds and doors to new possibilities. So you keep on inventing, reinventing yourself, and you reach the peak. So you will have to attack all losses, whether it's a breakdown or defects or scraps or stocks. So aim for zero, and then only you can survive. Let us see some examples, because examples are always better than precept. These are my experiments with waste removal. First one, the proposal for use of LPG instead of diesel for melting aluminum alloy ingots. So these are the aluminum ingots we used to use for our factory. We had a huge casting shop, aluminum casting shop, and we just calculated how much quantity required to melt 1 kg of aluminum alloy. For LPG, it is 0.07 grams, and for diesel, 0.15 liter, and it comes to 2.45. So the advantage is 2.65 per kg. So we were consuming around 70,000 kg, so the yearly savings was 22.3 lakhs. And cost of the equipment was 24 lakhs, and the return on investment is 1.07 years. Auto component machining is another example. In the US, that's the company where we're working. The Sandvik was supplying for ages, I would say. Nobody would dare to touch Sandvik. Everybody said that nobody will be able to supply at this rate. We went to Sumitomo, a Japanese company, and we took the proposal from them. And what they suggested, that their toolings is able to give a higher feed rate compared to Sandvik. Even if the price is same, but if your feed rate is increased by 0.001 inch per revolution, you will be savings $25,000. Another injector body. So tool life is 200. Sumitomo's life is 400. All the price was more, but savings is substantial. Apart from savings by increasing the feed rate. Ford long gear. Now see, Sumitomo gives 0.008 per revolution, each per revolution, whereas in Sandvik you can go up to 0.004. So you can finish it in 14 to 16 seconds, whereas you are taking 22 seconds. So the price wise also, this was cheaper, Sumitomo. In some cases it is higher. This is higher, but it doesn't matter. The life and other things, if you compare, you'll be gaining a lot. So these were some of the tools, combo tools they suggested, where you have step drill and some crowning at the bottom. And so you can do all the operations together, and this resulted in substantial savings. So merits: longer tool life, better cycle time, lower tooling cost, reduced inventory, high performance with the latest technology in coating. Especially I'll mention about the coatings. When I visited their plant near Chicago, we found their coating plant is superior to what Sandvik is using. They did not show us everything, because that was a secret thing, but they were confident that with this coating, your life will be double of Sandvik. So this is for the cutting tools. We worked simultaneously for sourcing nitrogen gas sourcing. If you call the other examples as Kaizen, this could be called as innovation, because nitrogen gas, we used to get 100 cylinders per day. Now manually shifting 100 cylinders per day is a huge task, and casual laborers were engaged to change manually. And in fact, the laborers, they came to me and told me, because since I was in charge of this program, so they said that, Mr. Bhattacharya, we are fed up. We cannot carry this every day. And so help us to do something, help us to come out of this problem. I gave a thought to it, and there were some reasons also. When you get the cylinders, purity, nobody checks it. Supply irregular, sometimes you get full supply, sometimes half supply. Quantity suspect, because whatever amount of gas is there in one cylinder, I'm not sure that they're correct or not. So there are two proposals. One is get a nitrogen tanker, no investment, but benefit is only 25%. Otherwise, you go for PSA nitrogen plant. It's a unique plant in the sense that there is a molecular seal, which when air is drawn to that molecular seal, what happens actually, all inert gases, they pass through the seal, but oxygen is not allowed. This is a German technology. and the benefit was 75%. Originally, we were taking at the rate of 15 rupees per cubic meter, and if you install the nitrogen plant, we calculated and found out it comes to around 5 rupees per cubic meter. So you can imagine the amount of savings and investment is 1 million. So we installed the plant in 2000 and still running without any problem. Savings achieved 1.2 million per annum, return on investment achieved within a year. So this is what is called innovation. So you will have to do both Kaizen and innovation simultaneously to improve your bottom line. Rejections, we wanted to reach 0 ppm. Now, how many of you have heard 0 ppm when if you are in manufacturing? Only Japanese people talk about this, but in India we have achieved it in our TVS group company, and our customers come in US, they were surprised, and we were just the best supplier in the world. I'll just go through this chart just to show you that what is the cost of quality in percentage of sales if your process goes on improving. If you are at a level of say 3.5 sigma level, your variation, with this variation, you are incurring a cost of 20% sales, and ppm if you see 22,750. If you go work on 6 sigma process, it is only 3.4, and percentage defects is this much. So cost of quality is 1 to 2% only. So we wanted to improve the process, and for this component. So we improved the inspection process. Inspection was a tough job because it has got 10 critical dimensions to be checked simultaneously. If one dimension is gone, so rejected, then this will not be accepted. It's a huge castings, and just see this is the fixture with probe. These are the probes which actually measures the diameters. These are mechanical probes, and it may be contactless probe also, air probe also, which we introduced in our American company. The screen will be like this when the component is not there, and these are the dimensions we wanted to measure simultaneously, and we put the component inside this fixture, and the screen shows like this. So we go on checking the components one by one, and you get a band like this, green band, which shows that you are within the upper limit and the lower limit. You get the histogram also for all dimensions. You get the control charts and benefits. If you see, it's what 0 ppm achieved with customer. Inspectors removed from the line. Customer was surprised, could not believe it, since ppm level came down to 0 from 2000. Supplier was just best supplier of the year. So same component, when we are machining, there was some waste. So those wastes we now removed. See the dimension tolerances. It's very, very close, 16.00 and 16.042. Surface finished 1.6 RA. Diameter 14 to 14.016. Parallelism 0.01 millimeter. This is absolutely accurate, and it's very difficult to get it with any tooling available in the market. So we approached a German tool, Mappal tool, and they supplied a lot of combination tools also they gave, and we maintained the parallelism to the extent customer desired. Now, if you look to the process was a horrible thing. It was full of machines only to make 600 pieces per day. If you talk for the first line, you see this one turning center, two turning centers, one horizontal machining center and two vertical machining centers. So you have one line here, one line here, and one line here. So 5 vertical machining centers were here. And you get an output of 600. So I thought, when the proposal was given to me, so I said that I want to remove all these vertical machining centers. I told my MD that these 5 machining centers are not necessary. He said that, what do you want to do, Bhattacharya? I said, I'll get you a machine from Germany. So we proposed a machine. It's a 2-spindle machine. The 2 spindles will be working simultaneously, and the output is the same, 600 per day. With automatic pallet changer, and even 5th axis was available. And this is how the picture came. And this machine was so accurate that it gave all dimensions the way we desired. And this looks like this, 2 spindle. So 1 spindle is here and 1 spindle is here. And if you see the tool changer, it is built around the main tools. That means the changeover time is very, very fast, much faster than conventional CNC. So 5 numbers vertical machining centers became surplus. These were used for expansion because we wanted to build up the machines. I purchased the machines for the expansion project, but I said it's not necessary. You take these 5 machines and put it there. We saved nearly ₹1 crore, excluding the cost of the, inclusive of the cost of machine we replaced. Seamless tube global sourcing. We are using seamless tube, bearing grade steel tube from a single source in India. So Indian Seamless was the supplier, and total demand was 100 tons per month. 80 tons steady demand and 20 tons irregular demand. Price at 15%. Indian Seamless came and told us that we cannot supply until you give us 15% price increase. But I was having a dialogue with the Japanese company, and they gave me 9 rupees per kg cheaper. So we removed, we shifted the steady demand to the Japanese company, but after 2 years, it again went to Chinese company, and say we saved another 8 kg, rupees 8 per kg, but we could not continue with the Chinese company, and ultimately we had to come out of the Chinese company and we went to Maharashtra Seamless inside India. So from India, 79, 70, 62. So these are the benefits, and had we stick to this, the Indian supply would have lost 5 billion rupees. So the lesson is, do not sit on your laurels in global sourcing. Situation is always volatile. Relationship is very important. Steel ball global sourcing. We used to take it from NSK, our technical collaborator from Japan, but they said that we cannot supply. So we shifted to ISKF in India, and we continued for some time. And SKF wanted to go out of the business. And a friend of mine, I went to UK, and then he said that he took me to a factory called Sperry Trafalgar, and we saw the factory, we approved the factory, and then they also supplied. And so this X per piece, it is 0.8% piece Indian company, and then 0.5x. So by shifting from Japanese company to Indian company, we saved $88 million. By shifting from Indian to UK company, 3.60 million. So it went on like this. So what is the lesson we learned? Find the right global source before your competitor finds him. So remember, your competitor was also looking for some global sourcing. So friends, let TCO be your mantra today. So what is TCO? TCO is nothing but total cost of ownership. Now let's look at some of the figures. This is for a new product development. Now, if you see that the estimated price is shown by the white boxes. So we estimated something and it came to 918 rupees. Now, decreased prices are shown in blue boxes. So these are the decreased prices when you made the product actually. And red one is the increased price, the prices. So ultimately we landed at 884, which is lower than 918. Now you see what are the things we have included. In-house machining, assembly. So all these things have been taken into account. So this is how you have to go about it. This, you can use it for existing process. You can use it for the new process or new. This is for TCO steel rod for 1/4 from one from Italy and one from US, and we found it US is cheaper, and annualized savings is rupees 7.54 million. So total cost of operation of any operation is sum of suppliers. So supplier has got certain costs, supplier side cost, then internal cost, then joint cost. So you add this together and then you get the TCO for subcontracted items. So this is the TCO for the subcontracted items. And if you look at this figures, 10.63, it is the raw material lost as process scraps. Now this raw material you could not get with the supplier because this was given to them for processing. And here you see process scrap, we reduced it. And they asked us, they gave us a figure of 180 rupees per hour rate for LMW CNC machines. And we broke it down to capital cost, tool cost, power cost, manpower cost, consumables, everything. And we made this chart. Multiplied by cycle time, so that gives the cost of the. So it went on like this, and we were able to convince the suppliers and bring down the prices. So what is the lesson learned? Neglect TCO at your own peril. So do not neglect TCO, you will be in trouble. So milk run system for incoming materials. No, we had a lot of problems in our this one in our Lucas TVS, and here the suppliers were supplying all around, located all around the factory. They used to supply to the factory, but the materials were dumped on the inside the inward stores, and there was complete chaos. So we said that we'll bring the materials from you. Everybody objected, but I said that it's a good proposal and nothing will not be spending much money on this compared to what will be we are incurring already. So it's a milk run collections, and on average 100 e-signals are sent and daily to the customers, and 6 milk run collections are done every day. So it used to deliver, it sends e-signals and then collects the materials. So benefits, it's a GIT delivery, just-in-time delivery, no inventory pile-up, get what is necessary for day's productions, no hassle for suppliers at the gate and store, vendors' logistic cost removed, and payment for materials consumed online, and substantial savings. So a good gesture always pays. Do not be penny wise, pound foolish. So safety item castings. Now you see Brakes India used to make steering knuckle, and there's a very safety item for steering. And if it breaks, you meet an accident. And this was the ppm parts per million with the customers. It's hovering around 1800, and we wanted to find out what is the defect. The defect was in the subsurface inclusions, and it is revealed only after machining. So Where it is located near the caliper. And where it is formed during the process, that also we found out from radiography. How to radiography, we found out that this is the place where it was formed. So we change the gettings, and instead of single getting, we put 2 gettings, and we ran the program on Magma software, which is available for design of the die casting toolings, and this is what actually happened. And we analyzed through Magma software, and this is what actually happened. So as a result of this, PPM came down to 0. So lesson learned, solve the problem yourself before customer points out. So please check up, this is another example, please check up whether your vendors are world class or not. So we used to supply the forgings from a factory called Impact Forge to Detroit, ATM annealing for annealing. It used to come back to Columbus and then again to our factory at Elgin, and then to Aurora for quenching and tapering, and then again used to come back to MTech, and then we used to deliver it to customers. So many movements are there. So can I do something on this movement? Because this nitrax, the rejection level is around 20%. So we suggested we wanted to utilize this company for everything, and that is what we achieved. So there are 2 movements, and this method reduced the cost by multiple by avoiding multiple movements of the trees. And this is the benefit, savings around $3 on a purchase price of $20 each. So 20% rejection avoided, analyst savings works out to be $115,000. So lesson learned, please check the capability of the vendor before you decide the movement of the materials. So sole sourcing versus multiple sourcing. I may take a little more, 5-10 minutes more to explain the things. Fuel pumps were being supplied by Lucas to our plant. So they were 100% for the Jeep, 100% for the cars. It was 20,000, and they had the monopoly, and they never maintained the quality. So if in one lot quality is good, in the second lot the quality is not good. So we wanted to break the monopoly. Now before that, I just wanted to go through a research paper which clearly shows why a supplier will not give the high quality product if it is a sole sourced. For example, if the contract is in just a moment. So say this stage is called the contract is agreed, and after there are 2 periods in the system. So in the first period, supplier supplies low quality, and the buyer decides to switch over to another supplier. So this will be the impact, payoff to buyer as well as payoff to the supplier. But suppose it doesn't switch over, then the next stage, the supplier, what he will do, he will again supply low. So if he supplies of materials of lower quality, this will be the result. This will be the payoff for the buyer, and this will be the payoff for the supplier. And this is the payoff for this. And in case in the first period, Lucas, say for example, supplies high quality, we do not switch over. And then in the second lot, he supplies low quality. And so what will be the payoff? The supplier, now if you look at the payoff figure, P is the price, K is the supplier's unit cost, and L is the low quality. That means low quality cost will be lower. So supplier, what he will do, and this will be if he is at this stage, then what will happen? He will earn maximum profit because P minus this KL is always lower than KH. So lower quality will have lesser cost, and so he will have a higher profit. Whereas in both the cases, this I have denoted by Nash equilibrium. Here, the supplier will never supply you high quality product. He will keep on supplying you lower quality products because he knows you cannot switch over. But you cannot switch over because you will have to incur this twice the setup cost. So supplier does not have any incentive for reacting in another way, and it results, and buyer does not have any other choice. So both will stick to this. That is what is called Nash equilibrium, and it will result in higher cost for assembler and higher profit for supplier. So this is a summary of relative costings, and here you will find that parallel sourcing is a better option. That is Japanese people found out, and that is what we adopted here. So we started developing the product with Bosch and Michael. My boss said that nothing, Bhattacharya, you cannot achieve it. I said, yes, I can do it. So we approached Bosch and they developed it, and after 2 years, this was the result. So we ensured that Micro supplied 100% to car unit and Lucas supplied 100% to Jeep unit. So we kept both the sources, but as a result of the savings, we achieved annual savings of 31.5 crores. So the lesson: break the monopoly and go for parallel sourcing as far as practicable. We went to China to get the materials on steel bars and coils. Steel price volatility went through the roof. Something to be done, and quality not to be compromised. China was way to becoming the largest exporter, still from largest importer the same. And we reached that time, and our volume was the attraction. We checked 5 steel plants in China, but ultimately we settled at Baoshan, still the biggest steel plants in China. And ultrasonic testing machine online was one of the plus points. Negotiations started, settled for rates varying from 10 to 20% less than Indian steel prices. Volume picked up to 50% of demand in 3 years, but savings was to the tune of 34 per annum. So this is some schematic diagrams for how we shifted. So you ultimately we went out of China because of the lot of problems we faced. They were not tackling the problems properly at the proper time. So the lesson is: go for global sourcing, but do not turn the apple cart. Creating value out of scraps. So somebody said that, why don't you, Bhattacharya, why don't you see some money in the scrap generated? We were generating around 600 tons per month of scraps, steel scraps. So these are the various forms, and these are the types of materials: low carbon steel, medium carbon steel, high carbon steel, alloy steels. And so when you are purchasing the materials, you purchase as per the grade. You pay higher rate for the higher grade, but when you sell the materials, you don't do that. So why don't you do that? So previous scenario and the present scenario, sold both as per the type and the grade of the materials, get a premium of ₹1 per kg for medium carbon and ₹2 per kg for alloy steels, generated an annual savings of nearly 1 crore of rupees. Gentlemen, you can get money out of anything, so you must have an open mind and proper eyes to detect the things. So lesson: do not let the savings pass through your fingers. So what was the result ultimately? When I entered the factory, that organization, I was somewhere in around 0001. This profit was negative, and by the time I left in, I think 2007 probably. So in 4-5, when we started the program, we said that we'll take the exports to the level of the in-country turnover. And so at the end of the 0405, you can see the profit was around 20 crores and total turnover is around 220 crores, and export and this in-country turnover is almost equal. And this is what happened because of the actions on both innovation as well as, there are hundreds of examples, but time will not permit me to explain all the things. So I try to find out what are the reasons for global sourcing. If I can get something in India, I should go for that. But the thing is that there are a lot of reasons. See, sometimes quality is not there, price is not there, and sometimes customer wants some materials to be sourced from their sources. And so that is the reason why sometimes you, even if you don't have, you have some sources in India, but you cannot go to them because of the customer's preference. So way forward, so it's a real war. It would be relentless war against quality, cost, delivery, and service. Gentlemen, it's really a war. So who would survive, perform, or perish? Is there any light at the end of the tunnel? Yes, I got this chart from a MIT journal, and on one side, you digitize or automate your supply chain. That means you increase your capability. And on the other side, you will have to sense and pivot the supply chain. What is that? It is called adaptability. So you must be highly adaptable and you must be highly capable. Sustain, you'll have to sustain, and sustainable advantage, you must have high capability as well as high adaptability. So who will survive? Only those who are having both high capability and high adaptability. You will have to sense where, if the supply chain is disrupted, so you'll have to take course corrections. You'll have to course correct the whole thing and find out an alternate route to service your customers. So mantra for restarting. So I'll just put it this way. You, first of all, you start reinventing, then prioritize, then boldly experiment, and then prudently scale up, and then skillfully pivot, or whatever it is. And if you go on doing like this, because you will have to reinvent yourself, you are not getting the material, as I said in the beginning, that people will not be there, machines will not be there, network will not be there, your suppliers may not be there. So you'll have to think about it, you to reinvent yourself. Some people of your people might be working from home, some may be working inside the factory. So all these things, you will have to reinvent yourself. Your old knowledge will not be valid here. And then you'll have to prioritize, then boldly experiment, then prudently scale up, and then skillfully pivot. And that is how you grow. So you would be dealing with unknown unknowns, not known unknowns. There are so many things. As I said, you do not know what you do not know. And when you come out of the storm, you won't be the same person who walked in. Wish you best of luck. So I'll just quote Rabindranath Tagore, who said, God, give me the courage to change what I can, serenity to accept what I cannot, and the wisdom to know the difference between the two. So you must have that wisdom. So thank you. For more information, visit